when I do parallel runs, I tell ROMs how to decompose it horizontally. The default thing is I tell it how many horizontal nodes in the X direction and the Y direction. And vertically, it doesn't split it up at all. In the time stepping, it doesn't split it up at all. So it takes each chunk vertically and runs that through time. And if in data assimilation, I run it forwards, backwards, forwards, backwards, forwards, backwards, it's the amount of time, all the iterations forwards and backwards increases the amount of time. But if you're going to have 1,800 processors, it's not necessarily more efficient just to chop it up into 1,800 horizontal grids, because with each cell, there is extra cells around the perimeter to get the derivatives right on the inside. So there's you add more tiles, so to speak, you decrease the efficiency. So there's a balance usually, and so that'll be a challenge for you guys who are working with the parallelization of ROMs. And so I'd love to work with you guys on ways around any kind of speed bumps. Okay, but before you do any of that, what do you have to do to begin with? Well, you got to sort of sign up with ROMs and you download the source code. There's something called subversion to get the latest version of the code. So when they find a bug, somebody out there finds it, they fix it, and you just type svn update, and it downloads the latest version of the code for you. Something called netcdf, so all the output files were something .nc. That's a special format that the scientific community has agreed upon, but you do need special input-output libraries. And I found that depending on which Fortran compiler you're using, you have to download those libraries or work it for that one compiler. So these are all headaches that you have to worry about once. They're headaches, but it's just once. You have to play with there's a compiler's directory, and there's a make file in there that you have to tell it where are your netcdf libraries, and you have to tell it what your compiler is, and all of those things. So that's machine-specific, compiler-specific. If you're doing the data assimilation stuff, there's something else called RPAC, which you also have to compile these libraries. And if you're going to plot up stuff, there's MATLAB routines. But how do you read these .nc files? They're not text files. They're unformatted files, so it can be pain to deal with. But you set it up once, and then you got it. So I would highly recommend going onto that site. There's a documentation. There's something called a bulletin board, which is useful to help. But there's no single manual where you can download the manual. There's no such thing. It's kind of spread throughout the code and spread throughout parts of the website. There's lots of information on the website, but no single manual. Watch out. And you know what? Ask me, and it might be that the simplest thing to do is to I could sort of really handhold you through one setup, and then once it's set up once, you can say, aha, now I can take that ball and run with it, and change it, and go with it. Yeah, I think that's all I have prepared. Any questions?
Do you have a good benchmark example that you could use?
This upwelling
you're working on right now.
The stuff that's an option. So the standard starting point is this upwelling run, which models wind blowing in a really idealized setup. So the bathymetry is really idealized. Might even be just in a flat bottom basin. So imagine you're in a bathtub with vertical walls. And imagine blowing wind across, and what goes out one side comes in the other side, that sort of thing. So really idealized, but it's the same mechanism. All the same finite differencing stuff goes on inside. You just don't have to worry about setting up an external file for your bottom bathymetry and your wind stress. So that's the default first place to go, and it might be that taking that default one and ramping up the resolution makes it run so slowly that you'll be able to see a big difference if you do it on massively parallel run or not. That was one of my ideas, was just taking the upwelling run, getting it running for you guys, and then seeing what you can do, modifying it for the NVIDIA stuff. Or I could give you, the bathymetry files that I've made for my stuff. So by no means should you guys go off and make your own bathymetry file. That effort wouldn't be a point to that effort. So I'm willing to go either way. I'd be willing, happy to work with you guys, see what works best. But I think the first cut should be try and get the default upwelling run working, because just to get it compiling and running takes an effort.
So what's your time that you're looking for? I mean, you mentioned that you want a run that behaves in some responsive, reasonable amount of time. What's your personal want for that?
We're working on a project now where we want to try to, once a day, send out an AUV, a little underwater robot submarine, send it out into Avila Bay, and we're going to program it, tell it where to go to measure data. And once a day we'll send it out, it'll spend hours and hours measuring data, comes in at the end of the day and get the data off of that, and overnight we will then assimilate that data in. So our time frame is, I want to be able to do, on a realistic grid, at 400 meters is way too coarse. I want to be able to do on a realistic grid, 20 to 50 to 100 iterations of several days worth of ROMS runs overnight. That's my time frame, at a very minimum. And so it's not feasible if I can't run it overnight, that kind of thing.
How long does it take to do it now?
And that depends on the resolution. So the super coarse resolution, you saw it running in real time. It was running, every 5 minutes, ratcheted off really quickly. But that was no data simulation and on a 400 meter grid. So we want to, it'd be wonderful to have like a 1 meter grid. Like, the AUV is 1 meter, meter and a half, 2 meters. So 5 meter grid, 10 meter grid is sort of like, would be wonderful. So as high a grid resolution as we could get. And it's not just, doesn't just scale up with grid resolution, because you go a finer grid and you need faster time steps. So it's not linear in the number of, in sort of your grid spacing. So basically I want to maximize the number of grid points I can squeeze in there and still run it overnight.
So then to further clarify this, when you use Rabble for 32 nodes, what kind of resolution and timestamp are you using?
So there, well, I didn't prepare a lot of hard numbers in this direction, but when I'm running on, I think we do like a closer to a, oh, now I'm blanking, but when we do this data assimilation and go back and forth, oh no, I know why I'm blanking. So I did the coarse resolution run with actual data. I actually assimilated, okay, pretend data. I assimilated synthetic data on the coarse resolution run, and just now we're transitioning to doing the high resolutions, and I haven't actually assimilated data on the high resolution run. So that's actually an excellent question. But suffice it to say, if it's fast enough now with the resolution we have, then I'm going to try and increase the resolution so that we can get a more realistic run, because we're really undersampling seriously. Other questions? So do you guys have experience with MPI? So right now it's in MPI. It's in Fortran. Sorry about that. I know computer scientists don't like Fortran, I get that. Fortran is actually plenty fast for doing scientific computation. A lot of scientists, some great scientists in the world, use Fortran. That's very modern stuff. But yeah, in the real paying jobs, they don't use Fortran. So it uses Fortran, and it uses, and Fortran is not hard to figure out. It's a lot like C. And it uses MPI. And you know what, the MPI, I tell it how many tiles in different directions, but I don't have to play with the MPI code at all. So that it once explains why I don't know a lot about the MPI, and it lets you off the hook from having to learn MPI. But I'd be really curious to know how you have to change it for the NVIDIA stuff.
Yeah, we just found out recently that the ROMs support OpenNT, and what is that have to do with MPI? Is that like a replacement? Is that an alternative, or?
Yeah, it's an alternative.
I heard it's maybe like one of our group members found out that maybe it's closer to, to C, like,
Oh, really? Well, that's interesting. So,
I don't
yeah,
know if you-
right, I didn't even
your
mention
thoughts
that
about
yeah, it does do OpenMP, which I understand is shared memory. So, but MPI is distributed memory, and so the thing is, my understanding of it is that if you're going to do massively parallel stuff with like independent machines, you can scale it up to bigger and bigger problems. Please correct me if I'm wrong. On MPI is sort of clusters like Ravel. It's you can farm out pieces of the code to the completely independent computers, and so that's an MPI kind of a thing. But then if they're going to share pieces of the memory, then you need OpenMP.
Yeah.
And yeah, I understand you can do both. I don't know if you can do both at the same time, but you can do one or the other. And I don't know of sort of my impression is with OpenMP you have to do sort of, you're limited in the number of processors. You don't often have something with many processors that all share the same memory. But I'm not sure about that. But yes, it can do OpenMP. So is that more similar? Is that more similar to the
Because our
philosophy?
our system is gonna have like several Tesla computer cards in one machine, and our initial goal was to try to run it on that machine as opposed to several machines. So do you think maybe OpenMP would be an alternative, or maybe
I haven't tried OpenMP, but yeah, it's set up flexible enough to run it, and I'd be happy to work with you to figure out the ins and outs of it. But yeah, it is set up to be able to run shared memory, distributed computing.
Do you know what it uses when it's not running in parallel? When it runs on just one machine, is it using OpenMP or is it something straight?
It's I don't know. I don't think it's using anything. If you're not